Hello, everyone. Welcome to another episode of the Data Standard Audio Experience. Today, I have James Bullard, the CTO of Pendulum Therapeutics. And today, we're speaking about technical tools and just how they can be applied within different companies and industries. So, welcome to the show, James. I'm so excited to have you today.
Yeah, thank you. And thank you for having me.
Yeah, absolutely. Could you tell us just more about your background and go ahead and introduce yourself?
Right. So I'm Jim Bullard. I'm currently the CTO and co-founder of a company called Pendulum Therapeutics. It's a company that me and my co-founders started about 8 years ago. And my two co-founders, Colleen Cutcliffe, who's the CEO, and John Eade, who is the CSO, we work together at a company called Pacific Biosciences, which is a long-read DNA sequencing technology company. Where we worked, we had really enjoyed working together. We had a great working relationship, so we felt that we'd be able to leverage some of the long-read DNA sequencing technology in the growing space of microbiome research. The microbiome, I'm sure most listeners are familiar with, but it's kind of the bacteria in your body that affect your health and are commensal with you. So they can be beneficial or they can not be beneficial. And so we really wanted to see whether or not the new technology of long read sequencing could break up a log jam in this space. So at the time, there were a great number of publications showing correlates of the microbiome with health states. There still are a number of these, but as a biochemist by training, Colleen, and a physicist by training, John, and a statistician by training, we really focused on kind of good classic experimental design questions. So we really wanted to take a lot of the research that had been done in academia and see if we could make some translation to products. The three of us had felt strongly about making products for people. We feel that it's a really important aspect of, what we do. So this work kind of started because at Pacific Biosciences, where we three worked together, I was doing the data analysis for a lot of the molecular biologists and the biological team, and they really struggled with representing experimental designs and testing hypotheses. So I worked on tools to help facilitate the analysis, to enable them to kind of see their data, use their data, and really kind of do the optimizations they wanted independently of a statistician. And so this data analysis platform really was kind of a jumping off point for what we thought would be a way to make headway in the microbiome space. That work was a continuation, I think, of a lot of work I did at my PhD, which I finished in 2009 at UC Berkeley. I was in the Department of Biostatistics, and my advisor, Sandrine Dutoit, was super helpful and supportive of the work of kind of tool building for biologists, medical doctors, epidemiologists. There's a recognition that high dimensional data and the growing data deluge required new kinds of computational tools and visualizations for users to make progress in analyzing their data. So I actually had returned to do this PhD after I had been a professional software engineer for about 4 or 5 years. And I was basically a server system programmer in Java and Scheme for a company called Perceptual Robotics in Chicago. This was a great experience. I highly recommend the startup experience for young developers, young engineers, because the exposure one gets to a lot of technologies and a lot of responsibility is instrumental in what kind of happened next in my career. I was able to really go into my PhD with a strong knowledge of a really useful tool. Software and computer programming is really instrumental in data analysis these days. And I think that was coupled with my advisor's desire to deliver tools to end users and really make tools available to biologists so that data analysis could be scaled up proportionally to the amount of data that we were collecting. And that was fortunate. My career is a lot of fortunate examples of being maybe in the right place at the right time. At Northwestern, where I did my computer science undergrad, they had recently started an incubator. It was around 2000, and incubators I didn't know about, but there was a technology incubator. There are a lot of companies there, and I just landed with one company and gained a lot of great experience as an engineer. I was very fortunate to be at the place at the time at Northwestern where I learned Scheme, a programming language that I think everyone should start with. And I think that experience was formative for me in understanding kind of tool building and problem solving with computers and statistics. And basically, after graduating from college, I worked for a while. Then the dot-com bust happened. I'm sure it's affected a lot of people. So couldn't find a job that I wanted. And I went abroad for a year and got really interested in public health. That's when I went back to Berkeley, started off as a master's of public health and epidemiology, but realized quite quickly that the right place for me was in statistics and helping scientists solve problems with data. So that's kind of where I am today, back full circle, still building tools, still helping users solve problems with statistical methodology and computer software.
Yeah, no, and that's great with the journey that you've had to figure out kind of where you want to be today. And I'm sure you work with a lot of different technical tools. And I wanted to ask that what are some technical challenges that you've seen that kind of come with building these good statistics for long run processes?
There's a lot of ways I think about that in a company, especially companies that are building products. We have a lot of product iterations, a lot of development work that goes on for years. So for instance, if we're optimizing some aspect about our process and we have some metrics for that optimization, what are important characteristics of those metrics so that the optimization problem over the course of years and different team members will be stable? And I think that oftentimes the best metrics and the best algorithms are kind of more stable, tried and true techniques as opposed to more advanced machine learning techniques. I've seen a number of times where in long running development work, machine learning processes and training of machine learning algorithms has made it really challenging to move development forward rapidly in the face of slightly changing requirements. I would say that in my current work, I really focus on distilling metrics down to the simplest kind of metric that we can use to optimize a process that will be hard to, it will be very robust. I feel like robustness is an area where machine learning technologies are very currently weak in many ways. I guess weak is wrong. They're subject to training constraints, and those training constraints in the context of product development often are challenging at best to implement well. I've seen that really slow down the development of various optimization processes. They have a place, but in a number of cases, when you're kind of constantly iterating through a series of candidates, then it can be misleading because the training might really be necessary to run each and every time that you're kind of subjected to a new set of problems. And that is challenging.
Yeah, absolutely. And I completely agree. It sounds like something that a lot of different people in your field kind of have to work with and kind of have to deal and solve with. So thank you so much for sharing about that. I want to talk about machine learning now. A lot of different companies and industries are using this just because it's the hot new thing and everyone wants to use it because it's really cool and super complex. And it's built a lot of traction over the past recent years. But it's not always a necessary tool to be using because there's a lot of simpler methods and traditional methods that can be used rather than complex machine learning. So my question to you is, how do we know, or how do companies or industries know when to use machine learning versus something more simpler like a traditional statistics method?
I think that's a great question. I think that's a challenge. I think many candidates, for instance, many people from other departments will often ask about whether or not we're using this or that technique. And sometimes I feel I could disappoint someone by saying, in fact, we are not often leveraging those techniques. I think there's kind of some heuristic ways that I think about the problem. One way is the training data. Right. So in some sense, what is the amount of training data? How relevant is it to actually the problem? How generalizable is the estimator that has been trained? Once an estimator has been trained, how kind of robust is it in the face of new data? How easy is it to get really good training data? I mean, are you rich in training data? In some cases, if you're very rich in training data and weak in physical understanding of the system, then it is a very good technique to gain understanding of what the important variables are in a process, what is affecting the characteristics of, some process. I think machine learning has a lot there. I think machine learning is actually quite useful in exploratory data analysis. I use techniques like random forest all the time to get a sense of, what's important in different data sets before I even really jump into a kind of explanatory models. there, I think it's another important aspect, which is how much are you required to explain why this does something, or how much are you required to leverage your knowledge of how something works to improve it. So for instance, in a biological or physical process, it's often very important to have a good understanding of how it works. As you kind of have a model for the system, it gives you natural things to improve or to try to improve. So it creates a framework for kind of more sound continual hypothesis testing. And I think machine learning is at the phase where it's very popular because it's used in a lot of cases where other techniques wouldn't have worked. The high dimensional aspect of machine learning that is enabled by some of the newer techniques can really solve problems that were, I would say, intractable with other traditional techniques. The balance of overfitting in many cases, when you have these really huge data sets with high dimensions where a physical model is not obviously available. I would lean on machine learning techniques. They're much more heavily. Where I think we can reason about processes, then I want to see more standard experimental design, analysis of variance, maybe some inference. But largely, I think that's the distinction is really about what do you have access to in terms of training data and what the product has to be. How much do you have to explain it to people, and how much do you have to communicate about how it works? And we often have a lot of that in a biological system.
Yeah, definitely. And it's clear that you sound like a math person, very passionate about statistics. So I think that's a very important tool to also be using in a lot of the different programming tools that we're using in addition. And in terms of just a pipeline, in terms of pipelines that different companies are kind of using to work with different projects and products that they're making, can you walk me through how does a company kind of figure out what the right pipeline is to be using for their project?
So I think that is a solid question that I've wrestled with in a number of contexts. I think one interesting thing that everyone has experienced in the last 10 years is the explosion of the cloud. And many listeners will be familiar with traditional cluster type systems where computing model is available to one that is quite a bit different than what is optimal in the cloud. And so one of the areas that we as a company at Pendulum have struggled with as a cloud only company, what is the right pipeline to use, given that a lot of our candidates, a lot of the people who join our company are coming from an academic context where clusters and traditional HPC solutions are much more prevalent. And so we wrestle with a lot of the translation of cluster-based HPC versus cloud-based. And I think now it's much clearer how to leverage the cloud than it was when we started. I think there, however, is still a number of ways to think about what a pipeline needs to do and what it's trying to solve. One area where I feel there's a lot of kind of back and forth is an area where are you doing a constraint solving problem, or are you doing more of a shell scripting type solution? And, there are certain problems that lend themselves better to kind of setting up a pipeline so that each kind of computation is dependent upon previous computations and then subsequently. So when you get the result of the pipeline, it's kind of known what it is. You don't have to rerun it because you know all the dependencies and all those dependencies haven't changed. And therefore you can it's stable. And a lot of the pipelines that I've been interested in lately have been around that. Allowing users to really think very little about what is created or what computations are done, and then, kind of leveraging those in subsequent computations in a caching fashion. There's a lot like, make files in the cloud versus, just logging into a cloud machine and running scripts. I do think that Amazon, for instance, which is the largest player here in the cloud space by a lot, they have really actually not done a lot in terms of servicing, the bioinformatics, biology communities with respect to pipelines. I mean, they don't really offer a kind of turnkey pipeline solution for doing these kind of computations. So I think that that's an area where we'll probably see some improvement there, and then maybe there'll be kind of more standards. I won't be surprised if in the next 5 years, there's more of a standardish answer to this, kind of as we all move to the cloud.
Yeah, definitely. And the cloud in general has been really, a lot more companies are really starting to use this and really processing their data more and being more data driven nowadays. So it's a very important tool to be using for many different companies. I wanted to say thank you so much, James, for joining us today. It was such a pleasure to have you on the show. Where can everybody find you online to connect with you?
Probably the best place is LinkedIn. I think that's the only social network I currently am on, or email, which is my first and last name at pendulum.co. I think, we are always hiring good candidates. We are always looking for strong scientists. And if you're interested, we have a lot of really important, interesting problems to solve. And we're a very flexible work environment for people to kind of really shine in what they do.
Yeah, perfect. And to our audience, for more information on the data standard, you can find us at www.datastandard.io, as well as on our LinkedIn and YouTube channel. And thank you so much, James, for joining us. It was such a pleasure to have you on the show, and I hope to speak to you again soon.
Thank you. And thanks again for having me.